Right, as we said earlier, we take measurements and then oftentimes we do math with these measurements. And so our numbers and our math needs to reflect our level of precision. And when we have multiple measurements and we're combining them together through some mathematical operation, our overall answer for that, mathematical equation, its precision is going to be limited by the least precise measurement. So limited by the least precise measurement. And so let's take a look at how we're going to keep track of our sig figs and use them in mathematical operations. So let's take a look at multiplication and division first. So they have the same rules. And when you're doing multiplication and division, it's based on the number of sig figs. So for example, if I have 5.03 times 108, 452 times 0.20, right? And we're assuming that these are all some types of measurements. If you type that in a calculator, you'll get 109,102.712. And now let's think about how much precision our answer has. And so again, it's based on the number of sig figs, and our answer has to reflect whichever measurement has the least number of sig figs or the least amount of precision. So if we take a look at the first number, we've got 3 sig figs here. If we take a look at this number, we've got 6 sig figs here. And then if we take a look at this number, we only have 2 sig figs, right? The 2 and the 0. The leading 0 obviously doesn't count as a sig fig. And so this is our least precise measurement. And so our answer can only have 2 sig figs. And you start counting from the left to the right. So this is our first sig fig. This is our second sig fig. And so that's our uncertain digit. And we have to stop right there. And so our answer can only have 2 sig figs. And so we're going to round that number. And since the number to the right of it is a 9, we're going to round that up. So this answer would change to 110,000, right? Our answer can only have as much precision as our least precise number. In terms of rounding, if you don't know the rules for rounding, what you want to do is you want to look at the number to the right of the number you are rounding. If that number is 0 to 4, then you round down, or the number to the left of it stays what it is. If the number is between 5 and 9, then you round up, or that number goes up 1 number. So for example, let's do some rounding. Okay, so I've underlined our uncertain digit, right? So this is our uncertain digit. So what we're going to do is we're going to take a look at the number to the left of it. That is a 4. So we're going to round that down. And so we're just going to keep the 2 as it is. That would become 2,200. This number right here, right? The number to the right of our uncertain digit is now above 5. So we would round that 2 up. So this would become 2,300. For this next one, right, this number to the right of it is a 5. That also rounds up, so it's 2,300 again, right? So basic rules of rounding shouldn't be too difficult. Now, whenever we're doing mathematical operations, oftentimes we do more than one mathematical operation, right? First, you'll divide by something, then you'll multiply, then you'll add, you'll subtract, so on and so forth. You're not allowed to round until the very end. So no rounding until the end, right? Because every time you round, you add error. into your answer and into the measurement, right? So you're not allowed to round until the very end. The best way to do this is to plug all of your math into your calculator at once, and then copy that number down, and then figure out which place you need to round to, and then round that number. If you do intermediate steps and do rounding in between, you could end up with the wrong answer. Let's take a look at an example of that. So we have 6.6 times 6.6 divided by 6.6. So multiplication and division are inverse operations. So for example, if you multiply something by 2 and then you divide something by 2, they just cancel each other out. And so we can see we have times 6.6 and divided by 6.6. So these two should obviously cancel each other out, and our answer should be 6.6, right? So let's take a look at what happens when we do this. So if we do 6.6 times 6.6, and we type that into our calculator, we get 43.56. And then this is our uncertain digit, right? Both 6.6 have 2 sig figs, so our answer can only have 2 sig figs, right? That is the uncertain digit. Now, if you were to do this incorrectly, and then you were round in this intermediate step, you would round it to a 44. But as soon as you do that, you add some error. Right? You added error by rounding prematurely. Right, so let's take a look at when we do this 44, and then we divide it by 6.6, your answer comes out to be 6.666 repeated, right? Again, if we think about how many sig we have here, we have 2 each, so that's our uncertain digit. So then your answer round to 6.7, right? That's not 6.6, and that is not the correct answer for these mathematical operations. So only round at the end. The best way to do this is to just type in your calculator 6.6 times 6.6 divided by 6.6, and then you'll get the answer of 6.6. And then if you did have to do any rounding, this is when you would do it, and you would say, oh, I only go to 2 sig figs. So no rounding until the very end.